That last clip got cut off, but we were factoring 3k out of negative 6k. When you factor out the 3 from negative 6, you're left with negative 2. When you factor out k from k, well, the k's are going to cancel. No more k's. Negative 2. That's your final answer. We're still on number 7. This is polynomial number 3. We have 100z to the 9th plus 50z to the 6th minus 75z to the 5th. Once again, we're going to start with the coefficients. 100, 50, and negative 75. What is the greatest common factor that just the coefficients have in common? Well, 50 is not a factor of 75, though it is a factor of 100. Let's divide that by 2. How about 25? 25 is a factor of 100, and it's a factor of 50, and 25 is a factor of 75. It goes in 3 times. So we know 25 is the GCF for the coefficients. Now we have z to the 9th, z to the 6th, and z to the 5th. The most z's that they have in common would be a z to the 5th. Now we're going to factor out that GCF. We have 25z to the 5th. We're going to factor it out of this polynomial. So if we factor out 25 from 100, or divide 100 by 25, you would get 4. If we divide z to the 9th by z to the 5th, we have z to the 4th. The exponents just get subtracted. The next term, we're going to factor out a 25 from 50. That's just going to leave us with 2. If you factor out z to the 5th from z to the 6th, leaves you with just one little z. And then last, we're going to factor out 25 from negative 75, which will be a negative 3. And since we're taking z to the 5th out of a z to the 5th, there's no z's left. So we have 25z to the 5th, and then in parentheses, 4 times z to the 4th plus 2z minus 3. Moving on. Number 8. It is very important that you know how to factor a trinomial. The word factor, that means we're going to be taking this trinomial and turning it into factors. So we have b squared plus 8b plus 7, and we're going to turn it into factors, so we open up our factor brackets. Because this first term is b squared, that tells us that b is going to be the first term in each factor. Now the number that goes here and here have to be factors of 7, because they're going to multiply to get 7, but they also need to add to get 8. Well, this is an easier example because the only way to multiply two numbers to get 7 is if they're 1 and 7. And 1 and 7 do add to get 8. So there's our final answer. On to B. Factor this trinomial. N squared plus 4n minus 12. Well, open up your factor brackets. Because the first term is n squared, we know that the first term in each factor will be an n. N times n is n squared. Now the number here and here have to be factors of negative 12. It means they have to multiply to get negative 12. And they have to add to get 4. Let's see, if we did 3 and 4, that's not going to end up being 4. What about 6 and 2? But since negative 12 has the negative sign, that means one of these terms has to be negative. Since we have a positive 4, that means we want the 2 to be negative, because 6 and negative 2 would make a positive 4. Okay, so 6 times negative 2 is negative 12. 6 plus negative 2 is 4. C. Factor the trinomial. M squared minus 10m plus 9. Well, first term is m squared. So after we open up our factor brackets, we know that the first term in each one is an m. Now, we need two numbers that multiply to get 9, but add to get negative 10. Well, there's not any two positive numbers that will ever be added together to get a negative number, meaning they're both negative. So the only way to get 9, well, there's two ways. 3 and 3, or 1 and 9. Well, a negative 3 and a negative 3 is not going to make negative 10. But a negative 1 and a negative 9 will. So we know our factors are m minus 1 and m minus 9. Okay, on to part D. We actually have a typo here. This is not a trinomial. This is a binomial. There's only two terms. We know that there's going to be factor brackets. Now, if you choose to solve this one using the pattern that it is a difference of squares, you may do that. Or you may do it just how we did these other ones. We need a number that's going to multiply, two numbers that multiply to get negative 1, and then add to get, well, the coefficient of the middle term must be 0 because it's not there. Let's see. Two numbers that multiply to get negative 1, that would be negative 1 and 1. So we have our k in the front. We'll put a minus 1 and a plus 1. Number 9. You will be asked to solve polynomial equations. If you follow these 4 steps, you should come out to the right answer. First step, we're going to factor out the GCF. Then we're going to factor the trinomial. We're going to set each factor equal to 0, and then solve for x, or whatever the variable is. Okay, so we are given this polynomial equation. Step 1, factor out the GCF. Well, what is the GCF? We've got 5v squared minus 30v plus 40. Let's check the lowest term and see if it's a factor of the other numbers. Well, 5 is definitely a factor of 5. 5 is a factor of 30, and 5 is a factor of 40. So we're going to factor out a 5. So we divided every term by 5. Step 2 was factor the trinomial. Now here's the trinomial. The 5 will stay in the front. He's just a factor. We're not going to mess with him. But we need to factor this trinomial. So we're going to rewrite the trinomial as two factors. V squared's in the front, so we know that v and v go here. Now we need two numbers that multiply to get a positive 8 and add to get a negative 6. Well, there's no way to have two numbers that are positive multiply to get 8, but then add to get negative 6. So that means they must be negative, because a negative times a negative would make a positive. Now what two numbers multiply to get 8 and add to get 6? 4 and 2. Negative 4 times negative 2 is positive 8. Negative 4 plus negative 2 is negative 6. On to step 3. Set each factor equal to 0. Well, 5 doesn't have a v in it, so it's not going to get set equal to 0. But v minus 4 has a v in it. We'll set that one equal to 0. And we'll set v minus 2 equal to 0. Step 4. Solve for x, or whatever the variable is. Our variable is v. If v minus 4 equals 0, then v must be 4. If v minus 2 is 0, then v must be 2. And you're done. Part C. We're going to follow the same 4 steps. Step 1 was factor out the GCF. We have 2k squared plus 22k plus 60 equals 0. So we're just looking at these 3 factors, and we're going to check and see if this lowest number happens to be a factor of the other 3. Let's see, 2 is a factor of 2, 2 is a factor of 22, and 2 is a factor of 60. So we know that the GCF will have a 2. There's not any common variables, so we're just factoring out a 2. Alright. The next step was factoring the trinomial. So we're going to take this trinomial and turn it into two factors. Since the first term is a k squared, we know that each factor will start with k. K times k is k squared. But now we need two numbers that multiply to get 30 and add to get 11. So we've got 30. We've got, it could be 2 and 15. It could be 3 and 10. It could be 5 and 6. So which of these sets of factors adds to get 11? This one. So we'll have plus 5 and plus 6. Notice how order doesn't matter. If it was k plus 6 and k plus 5, same thing. Step 3. Set each factor equal to 0. So we can't set 2 equal to 0, there's not a k in it. But we can set k plus 5 equal to 0, and we can set k plus 6 equal to 0. Now we solve. If k plus 5 is 0, then k must be negative 5. If k plus 6 is equal to 0, then k must be negative 6. On number 9, we're going to move to part D. Now, D is similar to B and C. We need to follow the same 4 steps, but I did not provide the outline for you. I want you to try to do it on your own. So we know the first step was to factor out the GCF, and here our GCF would be 2. So we factor out a 2. Now that we've factored out the GCF, we need to factor the trinomial. Since the first term is p squared, we know that the first term in each factor is a p. Now we've got the number negative 2 here. What factors of negative 2 will add to get 1? Well, there's only 2 ways to make negative 2. That's negative 2 and 1, or 2 and negative 1. Does this one add to get 1? No, that adds to get negative 1. Does 2 and negative 1 add to get 1? Yes, it does. So those are the numbers that we plug into the factors. Step 3 was setting each factor equal to 0. So we set this factor equal to 0. And we set this factor equal to 0. If p plus 2 equals 0, then p must be negative 2. If p minus 1 equals 0, then p must be 1. And you're finished. On to part E. We have 6v squared plus 66v plus 60 equals 0, and we're solving the polynomial equation. So finding those v values. Your first step is always factor out the GCF. Well, 6 seems to be a common factor here. Let's divide everything by 6. Okay, now that we have this trinomial, we are told to factor the trinomial. So 6 will stay where he is. Since we have a v squared as our first term, I was able to put a v at the beginning of each factor, since v times v is v squared. But now we need two numbers that multiply to get 10, but add to get 11. So we could do 2 and 5, or 1 and 10. Now which of these adds to get 11? 2 and 5 make 7, 1 and 10 make 11. So this is plus 1 and plus 10. Step 3 has us set each factor equal to 0. So we'll set this factor equal to 0, and set this factor equal to 0. If v plus 1 is 0, then v must be negative 1. If v plus 10 equals 0, move that 10 to the other side, v is negative 10.